Let's wait a billion years for this thing to start. First time I has to like load all the symbols and all the DLLs and things. That's why it takes a long time. Okay, finally. Okay, so where were we? We could play, we can shoot, and it explodes. Sick. So probably when it explodes, we wanted to like these physics objects. It would be cool if they actually like went out of the way, like they got some sort of impulse or something. So let's do that, because right now that's not happening. So the explosion doesn't really seem all that impressive. So let's add a world radial impulse at the point where the thing is hitting. Let's do that in code. And I actually have no idea how you do that, so let's find out together, shall we? It's probably some function somewhere. So how I would go about it if I didn't know the function name or know what to call and what the arguments are, I would just do a symbol search for like add impulse maybe. So let's see, what do we have? So we have add impulse at location. On the primitive component, that's probably not what we want. Body instance, we probably don't want any of these actually. So I'm just gonna do maybe just impulse. It's probably something in like world, I would guess. Maybe not. Let's do world impulse? No? World impulse. Radial. Something here, maybe radial. Root motion source, no. Okay, what is this then? Well, that's not very helpful. Okay, I couldn't find anything, so let's maybe see in blueprints if we can call something then. Because usually that will search a little bit better. So if I go into fuck projectile and just here on explode, I'll maybe just do add radial impulse and see what I can find. So here's add an impulse to all rigid bodies in this component radiating out from the specified position. And it's all rigid bodies in this component. So that will only add impulses to stuff that's on this actor. So that's probably not what we want. I want to do it on like everything. Add impulse. This doesn't seem like this is what I want. I think there should be one. I remember doing one at least. Angular impulse in radiance. Alright, let's just Google then. Fuck it, let's Google. Add impulse in world UE4. Let's see what we find. So let's see what we can find. An impulse to all actors, maybe. Doesn't really seem that there is anything. So maybe we need to actually... Yeah, we might have to just like loop through all the actors. Yeah, seems like we might have to do that actually. Unfortunate. Alright, so we will have to actually loop through all the components in a sphere, unless you guys can maybe find something. Maybe your googling skills is better than mine, but I'm not very used to using Unreal's physics, so I don't have this stuff memorized. But assuming there isn't one, then we would have to be like, when I hit something, then get all of the actors in sort of like a radius like this, get them all, and then add an impulse to them. So like add, that would be a radial impulse in that case. So we like sort of add an impulse at this location, radiating outwards like an explosion. Seems pretty cool, I think.
Try add force.
We can try add force. That's not what we want, but we can try.
force is only on a single body.
Radial as well.
Force, yeah, seems to also be on the radial on the primitive component. So
at location, but the one that's at location.
Yeah, add force at location is also just a single one.
Okay.
Yeah. So unfortunately, all of the add forces are working on one primitive component.
Remove context sensitive, maybe. I don't know.
Yeah, we can try. No, it doesn't seem like that. Oh well. It's fine. I think I remember there was one, but maybe there isn't. But it's fine. We can just do it ourselves. It's not that hard. So what we'll have to do is then get all of the primitive components in, because a primitive component is something that can handle physics. It has collision and it has physics. So we want to get all of the primitive components in the affected sphere. So we will sort of do like a sphere overlap check. Whoops, I need to get rid of this junk. So we'll do like a sphere overlap check where the explosion happens, and then we'll get all the actors in that sphere, and then we'll get all primitive components on that actor, and then we can sort of, you know, apply the impulse to all of those components. So let's do that. So to do that, we'll do sphere overlap. Here we have. So here in the Kismet system library, we have a sphere overlap actors. So this is a function we can call. It takes a world context. Whoa. It takes a world context object, which is a very common thing to have in functions like this. In functions that are, you know, looping through actors or doing, you know, level specific things that are like in the level is supposed to affect or read from the level, then you need to have some sort of context to know which world are we calling this function in, because like if we're playing in multiplayer, then we would have two worlds. We'd have one host world and one client world, or we might even have multiple client worlds if we're doing like four player multiplayer or so on. So then when we do the sphere overlap actors, then Unreal needs to know which world are you actually wanting to overlap in, because you can't overlap in all of them. You have to choose one world. So that is what this world context object means. You have to put in some U object that is in that world. So it might be an actor, it might be the world itself. It doesn't really matter. As long as it's one object that is inside of some world, that is enough for it to sort of figure out which world you want to overlap all actors in. So we give it a world context object, and then we have the sphere position. So that's, you know, the origin of the sphere, the radius. Here we have, okay, it's a horrible way to write it, but it's an array of t enum as bytes. Okay, it's just an enum, but whatever. So it's an enum of e object type query, and if we look at that, what that looks like, it looks horrible. So that's cool. And then we have an actor class filter. We have an array of actors to ignore. And then we have an output array of all the actors. All right, cool. So let's do this one at a time. Now that we looked at it, we know that it exists. We can sort of take it one step at a time. So in here in the explode, then we will do fetch all actors in a sphere. So then we'll call this Kismet system, what was it called? System library. There's a static function called sphere overlap. Why isn't it showing up? I might need to include it first. I'm guessing that's in Kismet. Let's see. Why am I getting no autocompletion? Oh well, I'll have to go in cold, I guess. So here we should get a sphere overlap actors. Has no member S. Okay, thank you. So there we go. And maybe now I get autocomplete. Nope, I guess not. Okay, so what was the first argument? The first argument was the world context object. So we have to provide any U object that is in the world we want to overlap our actors in. any U object, so it doesn't matter what it is, as long as it's inside a world. And we're an actor, so we can just pump ourselves into there, because an actor overrides from U objects, and the actor has some sort of world tied to it. Like our fuck projectile is going to be inside some world. So I'm just going to type this. I'm going to give myself as a context object. Oh, thank you for having autocomplete finally. So then we have sphere position, and that's going to be the origin of the sphere to do the overlap check-in. So that's going to be a sphere. So we can just type get actor location. So we're gonna do a sphere with origin being at the actor's location. Then it's a radius, and that's how big we want the explosion to be. So I don't know, let's type 500. I don't know, maybe that's too big. And here we have a T array. So I'm gonna say T. The prefix of T means this is a templated struct. So all templated structs don't start with F, they start with T. So that means the T array is a templated struct. It's an array, it's like std vector, or I guess list in C#, right? I think it's list. I don't remember. So inside of crocodile mouths are which type the array is of. So it's very similar to std vector and all that. So it was an array of object types. And what does this mean? What's an object type? Well, if we look at all of these guys, so if we look at, for example, this figure here, and we go to collision, and then I used what do you call it? Expand the collision preset here. You can see that every collision preset has an object type tied to it. And this is essentially which type of object to check when they're checking against the collision matrix. We haven't really talked about the collision matrix yet and what that is, but that's fine. For now, you can see that you can assume that everything that has a collision on it has some sort of object type tied to it. So this is physics actor, or player, for example, is gonna have the collision type pawn. That's our object type, so that's a pawn. The mesh is a character, it's also pawn, so the mesh also has pawn as a collision type. Projectile, we can check that one. It doesn't have collisions or whatever, but the sphere is world dynamic. So these are the different object types we can see in the world. So we want to essentially specify which types of objects do we want to consider for our overlap check. So let's make a T array. So we can make a T array of T enum as byte. It's horrible, but this is essentially just, instead of just making a T array with an enum in it, so instead of doing T array E object type query type, the difference between these two, it's object type query, but whatever. The difference between these two is that, remember what I said before, enums, use plain enums, like this one is just a plain enum. They are stored as integers, right? So these are glorified integers, so they take 4 bytes each. Each of these entries is 4 bytes. So if we made a T array with just the enum type, it will be a T array where each element is 4 bytes big. And since you can't set the size of regular enums, you cannot set a size override. What they've decided to do is make this T enum as byte type, this T enum as byte struct. And what this means is that it will store the enum as a byte instead of as 4 bytes. So this is just a workaround to make a regular C++ enum be only 1 byte in memory. So that's what this T enum as byte does. So that's why that's there. So it's just a little bit of ugly hackery to make it a little bit more performant. And we call the array, we call it types, yeah. So now we made an array. So this is very similar to std vector. You just make a variable with the array as a type. or with the std vectors type, and then we'll just add entries to it. So we'll just do types, add, and then we just add the enum. So we want to hopefully we can do this. So we'll do object type query. Let's say we wanna. Unfortunately, it looks like this, but maybe we can type like pawn. Maybe that will work, so we can actually type the name of the object we want to have. That would feel really nice, so we don't have to like get them. Let's see. Let's compile and see what happens. I'm so scared. I'm so scared. Why is it so slow? Please. I'm trying to hold a class here. Okay, there we go. Well, fuck. Okay, so pawn is an illegal qualified name in member declaration. Okay, so the problem here is that this is saved as an enum. So it has up to 32 of these object types. The problem is they are not defined in code. They are defined in the editor. So here in project settings, coalition, here it is. Oh, excuse me. Here's where the object types are defined. I think these are like defaults, but we can like make new object channels here, so we can make new object types here, and that will just simply take up another slot of this enum here. So it will be converted to a number like that. But that's annoying as hell. So it would be nice if we could just get the oh, here they are. Okay, cool. So here's some stuff. F collision response container. So here's some reserved ones. I wonder if we can get these somehow. Unfortunately, I'm very not used to tracing and using this stuff in, because usually you do this from the engine, from editor, or you do it from AngelScript. So I'm wondering if there's some way we can get like pawn. Let's just search. Let's just do a search. So I'm gonna find. Let's find. What's a good one? World dynamic. Let's find that one and see if someone else has solved this problem for us. So I'm gonna match case. I'm gonna match whole world. I'm gonna do file type CPP, so we only search CPP files. We don't search all the files, that INI files and all of that stuff. We only want to see it in CPP files. So let's see. Let's find out. It's done? Oh. Didn't find anything? Didn't find anything? Wait. What did I search for? World static. Final. Oh. Well, this doesn't seem helpful. Okay, well, fuck it then. Okay, we're fucked. let's just okay, let's just do this then. Okay, so fucking this is annoying. We need to reference. There's probably a good way to do this, and I'm just not experienced enough with reference these things in code that I don't know like the proper way of doing this. So I will just do this instead. Instead of making the array right now in code, I'm instead gonna make this as a U property. So we'll say, like, as a U property, we'll set which object types are we gonna query for an explosion, and then we can set that in Blueprint where we have sort of the autocomplete for each of the object type and so on. So unfortunately, I'm gonna have to do that. So that's annoying, but well, whatever. It is what it is. So I'm just in a fuck projectile. I'm gonna add this array here as a property. So it's gonna be an array of this E object type query. So which object types we wanna query for when we do the sphere overlap to do an explosion. Really annoying we have to do this, but so I will just make a U property here and make it edit anywhere. So there we go. So we will not set this from code. We will not add all of the object types here because we simply don't have access to them in an easy way, unfortunately, because they're set from the editor. So instead we will set these in Blueprint where we have access to which ones are which and what their name is and so on. I'm gonna comment this out for a little bit since we haven't finished filling it out. I'm just gonna comment it out so we can compile. Let's compile. There's probably some way to do this, referencing these things by name, but I'm just lazy and I don't want to look it up. It's just gonna waste time. It's probably easier to do a U property anyways. Wait for compilation. At least we can move around. That's fun. Look, I can hit this hole. Look. Oh, I'm sick. Okay, cool. So there we go. So it compiled. So now, if we go into BP fuck projectile, go into class defaults, then here we have types as an array here. So that's the one we made here. I should probably have named it something better than types. So let's actually name it. I don't want to recompile. Okay, let's just name it like explode overlap types, object types. Name it a little bit better than just types. That was not the best naming ever. Hopefully it doesn't take 2 years this time. Please, sir. Please. I wonder if it's slow because it's hot reloading, or if it's slow because it's just slow. Oh, there we go. Okay, it was a little bit faster. So now it's still called types. If I just reload it, is it called types? That's scary that it's called types still. I don't like that. I'm scared if I add this, if I add stuff here, it's gonna bust up. But we can at least see that if I add elements here, but with this plus button here, I'm adding elements to the array. And now I get a nice drop down of all of the collision types here, so I don't have to type them in by name or anything. I can just choose them from a list. So now we can easily add which objects we want to consider to be affected by our explosion. But I'm gonna restart because I'm scared that this is called type still, so that's usually a harbinger of trouble. So I'm just gonna restart because I'm paranoid. See if you guys is writing in. What? Sorry.
It's not paranoia if it's true.
Exactly. It's rational untrustworthiness. How are you guys doing, by the way? You haven't said anything for like 45
Pretty
minutes.
good.
This is like, wow, this is so cool. Finding world static and oh, that's so cool. I'm so happy I'm a programmer.
One thing I want to ask. Right now, it comes to loading up Unreal Project or compiling, and so it goes ridiculously slow for me. So I wonder if something I can do that could improve the speed up the process aside from the usual upgrading your hardware.
Is it just like taking long, like the little box is taking a long time?
The box for starting Unreal, and and I don't know what happened, but once when I was compiling, there came up some window about like a video memory or something, and then Unreal shut down.
Oh, well, that sounds like your PC is a little not the best. Loading times is all about your hard drive, how fast your hard drive is, and with your memory running out, that's you gotta download more WAM. So gonna get on that, unfortunately. Okay, so now we have the explode overlap object types, so that's what it should be called. So I'm not paranoid anymore. So let's add a few. We want to collide with world static. Actually, no, we don't want to collide with world static. It's time to me to actually explain what static and dynamic means. Static is stuff that should not move. I think that's pretty clear. Like this little box, this world box, it's not supposed to move. And it's actually marked as static here, which means it can't move in runtime. If I try to move this, you will get an error saying you're trying to move a static object. And when something is static, it doesn't move, then we place it in its own little category called world static, which means this stuff, it's a group together of all objects that don't move. That will mean it can cache it very efficiently, and it's much faster to look that stuff up. So if it's not moving, it's faster to put it in world static. And if you put anything that is moving in world static, then you're ruining the cache, so you're slowing down the game considerably. So don't do that. And world dynamic is the other thing. It's everything in the world that's moving. So they are dynamic. Yeah, that's everything else. So all of the boxes here would be in that. Well, they're not in because they're in physics body. But if they weren't in physics body, they will be in world dynamic. But they definitely aren't marked as static. They are marked as movable because these are physics simulated.
And by moving, you mean that either it's like moving by you moving it, or it's moving by something influencing it as well. That's also dynamic, I guess.
Yes, any kind of movements, even set active location or anything at all, changing these values in any way.
Yeah.
What is mobility? If static is if it shouldn't move.
Yes.
Or no, sorry. Yeah, exactly.
Yes, exactly. So this is if it should move or not. So if I mark it as static, that means I will not be able to change it in runtime. I will not be able to move it. It will just stand still. So if you're trying to move something, set at the location, but it's not moving, then you should probably check. Okay, is the object I'm trying to move actually static? You will also get a message in output log that you're trying to move it. So.
Yeah, sure, but like static and they're stationary to the right of it.
I've never ever used this. A stationary object can be changed in game but not moved. And enables cached lighting methods. I have no idea what this means. I've never used this. It's either static or movable. Those are the only two things I've used.
Alright, good.
This is probably useful. I just never looked up what it means. But yeah, so static, that also means it will receive baked lighting. So when you're baking, here build lighting here, which you probably want to do if you're an artist, then stuff that's movable will not bake the lighting. It will not have light maps because they're assumed that they will move around. So they will look a bit worse. So if your scene looks kind of trash after baking, make sure to look, okay, are your actors actually static? And also they're much more efficient. If they're assumed that they will never move, they can be put in more efficient change. Where they're never considered for movement updates, their bounce will be constant and so on. So there's a lot of optimizations Unreal can do if this is marked as static. So yeah, that's what that's for. So yeah, since world static will never be able to move, we don't really need to consider them for exploding. Like they can't move anyways. We'll just do world dynamic. We will do physics body. And let's do a destructible, I guess. We don't have any destructibles right now. But let's consider these three types for our exploding sickness. Cool. So now we made an array. So that was like 40 minutes of making a fucking array of enums. Thanks, Unreal. This sort of thing is always kind of a mess to work with. We have a lot of tools at Hazelight to work around these things because they are so annoying to work with, unfortunately. So it's fine if this is super confusing. As you've seen right now, I have to look them up every time as well because I never remember because it's so weird. So don't worry if this feels really weird and really stupid. Then you are right. Let's do 10 minutes. 10-minute break. So I'll see you guys back 14.